All right, you guys, today we're looking at just day 2 of angle arc relationships. So my instructions here are to find the measure of each angle, arc, or variable in circle O. So if we call it circle O, that means that O has to be the center of the circle. So keep that in mind. If a line or segment passes through the center, point O, then it's a diameter. All right, let me get in a little tighter just so you can see each graphic a little bit easier. So here we go looking at number 1. So number 1, here we can see that the vertex right here, it's on the circle. So the angle is going to be half of its intercepted arc right here. So the measure of angle V will be half of 76. So that's going to get us 38 degrees right here. So vertex is on the circle. The angle is going to be half of its intercepted arc, or the arc will be double the angle. All right, problem 2. So here we want to get to angle BAD. So I want to get to this one right here ultimately, but what I have marked is this part right here at 130. So I'm just going to keep my eye on the prize. I want to get over here. I want that angle. So 2 ways I can build towards it. I can see that this arc is 130 degrees. So this arc would have to be the remainder that gets us to 360 total. So 230 over here. And once I've connected to this arc, my vertex is again on the circle. So the angle will be half of the intercepted arc. So 115 right here. So that's one way to get to it. The other way I could have approached it is to build off the 130, get this angle right here. Vertex is on the circle, so half of its intercepted arc would be 65 degrees. And then I can see that together these angles form a linear pair. They have to be supplementary. So 2 ways to get to that 115. Right? Either going through the arcs, knowing that together they have to sum to 360, getting the 230 that way and then cutting it in half, or getting this angle really quickly and then connecting to its linear pair. So 2 paths to the same end result. Does not matter to me. All right, next one, number 3. So here I'm giving you this angle. Vertex is outside of the circle. And I want these 2 arcs right here. So what I do know is that this is a tangent, right? It's touching the circle one spot. This is also a tangent, touches the circle in one spot. So I know that the angle here and the arc right here have to be supplementary, right? I know that because I could connect right here and make an isosceles triangle. So right here then would be 116 degrees. So DF, the minor arc, is 116 degrees. And then the major arc right here has to be 360 minus 116. So that would make it 244. So 244 degrees right here. Okay, one other thing that I could do if I wanted to double check, I could do 1/2 the difference between 244 and 116. Okay, that's going to get us half of 128, which does get us back to 64. So just a good way to double check, make sure we solved correctly. All right, next problem, number 4. So here the vertex is inside the circle. So the angle is going to be the average of the 2 intercepted arcs. So x will be 1/2 the sum of 54 and 102. So average of the 2 intercepted arcs. So here we're going to get half of 156, which would get us 78 degrees. All right, let me look at the next one. So looking at 5. So 5 here, we want ultimately KL. So I want this measure right here. Okay, I have a couple ways to connect to that. So first method I could use is I could build off of the inscribed angle. So the vertex right here, right, it's on the circle. So the arc right here will be double the inscribed angle. So if I double the 50, I get 100 degrees right here. So if I build off of that, I know that these two arcs have to be the same measure because these chords are congruent. So if I have 260 degrees left over, I'm really just splitting it two ways and I get to 130. So both of these would be 130 degrees. So KL is 130 degrees. The other way I could have worked through it is to visualize the isosceles triangle, which is fine. Because if this is 50, these two base angles have to add to 130. And if I split that 130 in half, that means that the two congruent base angles would both be 65 degrees. So if I build off of that, if I take that 65 and I double it, I could get to this arc right here, which I already know is 130. So I can build off the triangle, or I can build off the chords. And we should know that arcs of congruent chords are going to also be congruent. All right, next one. So here, let me slide over a little bit. Here we're told that E is 75. So right here, that angle is 75 degrees. So we want this arc. We want this minor arc right there, which is labeled as Z. So here we know that the vertex, right, it's outside of the circle. So we should know that the angle of 75 will be 1/2 the difference between the two arcs. So 179 minus Z. So I've built my equation and now I just need to solve it. So I usually clear my fraction first. So I'm going to multiply each side by 2. So I have 150 equals 179 minus Z. Okay, take away the 179 from each side. So negative 29 equals a negative Z. Divide that negative 1 away, and we get that Z is 29 degrees. Okay, moving on to 7. So 7, we want this missing arc right here. We have the angle and we have the smaller of the two intercepted arcs. So we should know that the angle, which is 100, is equal to the average of the two arcs. So half of 46 plus x. So I've built my equation. I want to get to x. So I can multiply each side by 2. So 200 equals 46 plus x. Take away the 46 from both sides, and I get 154 equals x. And I usually just flip that around. So x would be 154. That arc would have a measure of 154 degrees. Okay, one other thing that I can point out, since 100 is the average of two numbers, if this one here is 46, okay, that's 54 degrees away from 100. So on the other side, this would be 54 degrees above 100. So this would be 154 right here. So again, if 100 is an average, it's equidistant to those two numbers. So 54 more than 46. So here we'd have to say, well, it's going to be 54 less than whatever this is right here, which is the 154. All right, looking over here at 8. So 8 here, I'm looking at the measure of D. So I want this measure right here. So my vertex is outside of the circle. So I know that what the measure of D is, let's call that x. X would be 1/2 the difference between those two arcs. So I'm looking at half of 120 take away 10. So half of 110 leaves me with 55. So the measure of D would be 55 degrees. All right, so that was a good blend of some sort of basic style of problems. Let's look at the back. So here on the back, looking at number 9. All right, so number 9 here, I'm looking at X. Let me just give a little arrow right there because that got cut off. So here I'm looking at X, but I can't solve for X right away because I don't have the two intercepted arcs here and here. What I can do is I can solve for Y. Let me call this part Y. So my vertex is inside of the circle, and I do know these two intercepted arcs. So I know that whatever Y is will be the average of 86 and 34. So 1/2 the sum of 86 and 34. So if I add those together, that is 120, and then I get 60 for Y. So Y would be 60 degrees right here. So once I get to Y, well then it's easy to get to X because X is the supplement of Y. They form a linear pair. So X has to be 120 degrees right here. All right, moving over to 10. So 10 here, I want X, but all I know is the larger of the two arcs right there, 252. Now here we do see that these are both tangents right here, so I can get to X if I know what this smaller arc is. Once I know that, these are going to be supplements. Again, if I connect their points of tangency, I really have an isosceles triangle. All right, so right now with that 252, if I build off of that, I know that that smaller arc would have to be 108. So here's my 108 right here. All right, so to get to X, again, because these are two tangents, I know that X and this arc of 108, they're going to be supplements. So I know right away that it's 72. But let's say that I forgot that shortcut when it's two tangents. I can still just do it like this. I can say that X is 1/2 the difference between 252 and 108. So half of 144 just confirms that we get 72 in the end for X. All right, next up, looking at 11. All right, for 11, what is it I want? I want L to E. So I'm looking for this span, L wrapping around here to E. I want that minor arc. So if I look at how many sides this figure has, if I view it as a polygon, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides. So this is really a regular decagon that is inscribed within my circle. So a regular decagon. I could also view it as, well, there's 10 congruent chords, right, that are cutting off equal portions of the circle. So we really have 10 congruent arcs. So if I take my 360 and I split it 10 ways, each of those minor arcs would be 36 degrees. So all the way around would be 36 degrees, but I'm just going to pay attention to the ones that I'm going to need right here. So those 4, if I add them up, right, 4 times 36 is going to get me 144. So the span from L to E is 144 degrees. All right, looking over at 12. All right, so for 12, I'm looking at PL. So I want this measure in the end. All right, so how do I get there? Well, I can't solve for that first. I'm going to have to solve for this missing minor arc right there first. So I'm going to call that x. So I can see with what's labeled, I have 100 degrees. That is the larger of the two arcs. Here's the smaller one that I need first. And then the angle with the vertex outside is 30 degrees. So I should know that my angle of 30 is 1/2 the difference between 100 and x. From here, I'm trying to get to x. So I'm going to clear my fraction on both sides by doubling, multiplying by 2. So 60 equals 100 minus x. Take away the 100. So negative 40 equals negative x. Divide by negative 1, and x is 40. Now be careful though, because that's not the final answer. That was just a piece of the puzzle that we needed first before we could move on to get to the measure that we want, this minor arc right here. So right now, we have our whole circle. We've used up 140 degrees. So if I look at what's left over, what's 360 minus 140? I'm left with 220. So since these chords are congruent, their arcs are going to match also. So I take that 220 and I split it in half and I get 110. So right here would be 110 and this would be 110 also. So the measure of PL is 110 degrees. All right, 2 more. So down here in 13, this is a question that is in the homework as well, but it's one I often get questions about, so I wanted to give you a little preview before you practice it on your own. So we're calling it circle E, so E is the center, and we have these 3 central angles that are in the ratio of 3 to 4 to 5. So not to scale, right, but we're told 3 to 4 to 5. We want to find the measure of each of these minor arcs. All right, so we've seen this before. If we have angles or arcs that are in a ratio, we know that we can just attach an x. So I can say, well, this is 3x, this is 4x, this is 5x. So this is the multiplier that is being applied to make it a larger angle measure. Now I can see that right here, this is a straight pathway. So together, those have to add up to 180. So I have 3x plus 4x plus 5x is equal to 180, right? I need to figure out what is the multiplier that's being applied to the 3, the 4, and the 5 to make it angle measures that will sum to 180. So right now I have 12x equals 180, and I divide by 12, and I get that x is 15. So my multiplier, x, is 15. So 3 times 15 would get me 45 degrees here. The central angle and its intercepted arc would be the same. The next one over, 4 times 15 would be 60 degrees, and 5 times 15 would be 75 degrees. So I can see that these 3 arc measures would be the same as the angle measures as well, and they sum to 180. All right, so now just filling in my gaps. The measure of AB would be 45 degrees, BC would be 60, and CD would be 75. All right, moving over to 14, last one. All right, so here we are given an inscribed quadrilateral. And we should remember that our angles that are in opposite positions, such as these right here, they need to add to 180. And so do these right here, they need to add to 180. So let's start with that. Let's solve for x, and then let's solve for y. So if I solve for x first, I can say that x plus 5/4 of x would equal 180. Okay, I want to clear my fraction, so I'm going to multiply every term by 4. Slide that up. Okay, so now I have 4x plus 5x equals 720. 9x equals 720. Divide by 9. And I get that x is 80. Okay, so right here is 80. And 5/4 of 80 would get me 100. So that makes sense. Those add back up to 180. Let's look at the y's. So again, opposite positions, they have to add to 180. So I know that y plus 4/5 of y equals 180. Okay, clear the fraction. Now multiply everything by 5. So now I have 5y plus 4y equals 900. So 9y equals 900. Divide by 9, and y is 100. So if y is 100 right here, and then I want 4/5 of y, well, 4/5 of 100 would be 80. All right, so I filled in my angle measures. So the measure of S is 80, and the measure of N is 100. That part's easy. But now I want NP. So if I want NP, I'm using the notation that says minor arc. So I'm reading it the shorter pathway from N to P like that. So if I take the angle right here, the inscribed angle, trace it over like that, I know that the arc has to be double 80. So I'm going to get 160 for this minor arc. Again, it has to be a minor arc because of the 2-letter notation, which means it's less than half of the circle. All right, that's all I have for today. Have a good rest of your day.